Okay, so today we're going to work on factoring still, but special cases. And you've got to be able to look at some of them and see that they're special before you start, because it's going to change the way you factor some of them. Okay, so starting with the first one, we've got factoring, and we're going to do x squared minus 12x plus 36. So right away, you can see that it is a trinomial. And so if that's the case, you're like, all right, trinomial, great. I'm going to factor it. I'm going to look for a GCF first, right? Is there a greatest common factor that you can pull out of these three terms? No, because it starts with a 1 here, right? And the highest is x squared. Okay, so you can use the way we started with, which we're looking for numbers now that multiply to give us what? 36. So we're looking for numbers that multiply to give us 36 and add to give what? Negative 12. Okay, so we need some factors here. What two factors would multiply to give us positive 36 and add to give us negative 12? Joelle, go ahead. Yes, negative 6 and negative 6. Okay, so here's why this is called a special factoring, because the factors are the same. All right, so when we factor this out, it's going to be x, right, and x to begin with, and it's minus 6 and minus 6. But that, although that is technically correct, you can go one more step in getting this factored, and it is this: x minus 6 squared. Okay, so remember when we did this in the first place, right? We learned that you cannot just distribute the 2 because there's a middle term, right? And so if you have a perfect square at the end, right, sometimes your perfect square, meaning like a number times itself, is 36. 6 times 6 is 36. Sometimes it's going to end up doing it where these end up to be the same factor, and then this is the final answer. Okay, so not much different there, right? You factor it the same way, just that at the end, if they are both the same, you want to put that together and make it squared. All right, next one. This one you're going to have to, is a tiny bit different. So noticing here, right, it says to factor z squared minus 9. First of all, that's not a trinomial, is it? It's a binomial. And there's not a GCF here, is there? Okay, so really what this is, if it tells you to factor this, we're really factoring z squared plus 0z minus 9. So in what you're really factoring here is you're looking for numbers that multiply to give you negative 9 and add to give you 0. What two numbers multiply to give you negative 9 but add to give you 0? Carla, go ahead. Negative 3 and positive 3 are the two factors, okay? So now this one I would factor out with this, z and z, right? And then I'd say minus 3 and plus 3. On this one, oops, can you do like we did above and make it just like this where it's squared? No. Why not? Okay, so this is the answer here. Okay. That's the answer. So the difference is, right, sometimes they'll come out to be the exact same number, a negative 6 and a negative 6, right? Then you can put it together and you can make it squared. But if one's a positive and one's a negative, all right, then you have to leave it. Also, if it tells you to factor something and it's a binomial, right, and there's no GCF, that means you want to add that 0 term in the middle and work with a trinomial instead. All right, again. So number, this one here, number 4, I took out problem 2 because it wasn't a good one, so we're skipping to 4. All right, on this one, 16x squared minus 81, right? So again, a binomial. Is there a GCF that can come out of there? No, there's not a GCF. So even if I add, but this is not a 1, right? So even if I add a 0 in the middle, right? So you don't have to write this down. Don't write this down. I'm just doing this for the sake of the notes. If I had done this, 16x squared plus 0x minus 81, right? So then, since that's not a 1, we would have to multiply 16 times negative 81, right? We have to do A times C. Somebody do that for me real quick. A times C in this case. 16 times negative 81. What do you get? A number, a big number. What is it?
Negative 1,296.
And then it would have to multiply. We have to figure out two factors that multiply to give us negative 1,296 and add to give us what?
0, 0.
That's tough. That's a really big number with a lot of factors, right? Okay, hold on. So now there is a cheat sometimes. If you notice that it's like this, right? In the beginning, and the first number and the last number are both perfect squares, meaning there is a number times itself that equals that number. We can't, and there's no middle term. We can just simply factor them individually. So what times itself will give you 16? 4, right? And so if I do this, right, and I make that 4, and I got to add an x, right? Because x squared, what times itself is x squared? X times x, right? I can do that. Because this is a perfect square and there's no middle term, what times itself is 81? 9. Okay, in order for it to cancel out the middle term and end up being negative 81 when I multiply it, are they both positive? Are they both negative? Or is one positive and one negative?
One positive.
There you go. That's the answer. Now, would that have worked up here?
I don't know.
What is the square root of z squared? What times itself is z squared? Z, right? Did we get that here? What times itself is 9? 3. And there's no middle term, so we made one positive and one negative. That would have worked here too, right? This only works if there's no middle term and the first and the last term are perfect square numbers, meaning, or letters, right? Meaning there exists a number times itself that equals that. Okay? All right. Last one then for today. Boop, boop, boop. Problem 5. So in this one, what is the factored form of 24g squared minus 6? Again, no middle term, right? But this time 24 is not a perfect square, so we can't cheat there. But is there a GCF? Yes. What is it? 6. Okay, let's take a 6 out of there. All right. So 24g squared divided by 6 would give us 4g squared, yeah? And then negative 6 divided by 6 gives us what? Okay. Okay, now don't get fooled here. I still have this going on, and I got a squared in there. Is 4g squared a perfect square? Is there a number times itself that gives you 4?
Yes.
What is it?
2.
2. Is there a something times itself that gives you g squared?
Yes.
What? G. All right. So hold on a second. If I want to, I'm trying to break this into binomials. I'm telling you it's going to happen. 2g times 2g is 4g squared. Yeah. Is there a number times itself that gives you 1? 1, right? There's no middle term, so what do I have to put in the middles of these? A positive and a negative. Booyah. Done. That's the answer. Okay? It is wacky. That's why these are called special cases. They don't happen all that often. However, we need to be aware of them. Okay, good. For online folks, all right, I will put this in, but we're going to do 8-7 today. We're only going to do the first section, evens, and the first section on the back, evens. Okay? All right.